In this video, we'll be solving linear systems by the method of elimination, which is another algebraic method. So previously we covered solving a linear system by substitution, but today we'll be solving it by using elimination. And don't forget, you can also solve a linear system by graphing, but hopefully you agree that solving a linear system by graphing is probably not the best method because you may not be able to get an exact solution. It's not going to be very accurate. But solve elimination, or in fact any algebraic method here, is going to be it's going to be accurate. Okay, you're going to get a beautiful solution. We're going to fill in these blanks, but they might not mean anything to you when we first fill it in together. But after we do the examples, I just want you to read it by yourself again. So don't worry if it doesn't make sense in the beginning. After we do the examples, then it makes perfect sense. Okay, substitution works by getting rid of one variable by replacing it into another equation. Okay, elimination works by eliminating either variable, so either x or y, through adding, subtracting, or first multiplying to make it possible to eliminate one variable. Like I said, if it does make any sense, it's okay. We're going to make sense of it once we do the examples. So you can either add or subtract to eliminate. So this is how it works. If the coefficient, okay, this is a word we learned in grade 9, if the coefficient of either the x or y variables are the same and they have different signs, so one is positive and the other is negative, so one of the coefficients is positive and the other coefficient is negative, but the magnitude of the coefficient is the same, then what we can do is we can add the equations, because if you add them, you'll realize that you end up eliminating the variable, and that's a good thing. Just like what you saw when you work with substitution, after you perform the substitution, you have one variable left over. So we're basically trying to do the same thing. You want one variable left over, but instead of substitution, you're eliminating. If they have the same sign, so the coefficients are exactly the same sign, so both positive, both negative, then what we can do is we can subtract the equations, and that will reach the same goal. You'll eliminate one of the variables. So we choose the correct operation based on the fact that you're trying to eliminate one of the two variables. You know what? The example will be explaining everything that we just wrote down. Okay, so you have two equations here. X minus 2y equals 13. And you have 3x plus 2y equals 15. This equation is actually designed very nice for us because we can eliminate, y. Now how do I know we can eliminate y? Because look, the coefficient for this term is negative 2. And the coefficient for this y term is positive 2. You see how they're both 2, a magnitude of 2, but one of them is negative and the other one is positive. So you can eliminate variable of y here. You can't eliminate x, okay? Why? Because you have 1x and 3x. Well, you can't eliminate x, but you can eliminate y. Sorry, let me go back to the point why you can't eliminate x, because if you add them, 1x plus 3x is 4x. If you subtract them, let's say you take equation 1 and subtract by equation 2, you get 1x minus 3x, which is negative 2x. So you can only eliminate a variable if the magnitudes of the coefficients are the same. Because if the magnitudes are the same, you can either add or subtract the equations to eliminate the variable. So the question is, what should we do to eliminate y? Should we add or should we subtract? Well, you can try it out if you don't know. So negative 2 minus positive 2. Will that eliminate y? No. Negative 2 minus 2 would be negative 4, right? So no. So what you want to do is add. Let's try adding. Negative 2 plus 2. Yeah. Negative 2 plus 2 would be 0. So that's what you want to do. If the signs are opposites, right, negative and positive, you want to add. So add equation 1 and equation 2, and you'll see you're eliminating variables. So what we're going to do is add the two equations. So x plus 3x, that becomes 4x. Negative 2y plus 2y, that's going to be 0y. You don't really need to write it down, but I'm going to write it down since it's our first time solving a system by elimination. And then 13 plus 15, 28. And look at that. Y is eliminated, right? You didn't really need that there. You have 4x equals 28. That's beautiful. That enables you to solve for x. Let's write that down. 4x equals 28. Divide both sides by 4. X is equal to 7. Right? So really, substitution and elimination are different, but at the same time, they're trying to do the same thing. Once you perform the substitution, the variables, you only have one variable. Okay, you either express it in terms of just x or in terms of just y. Now here you add and subtract the equations from one another, and the goal is to eliminate one variable, because if you eliminate it, it's only in terms of x. But if you eliminate an x, hopefully you can imagine, you can then solve for y. So it doesn't matter whether you eliminate x or eliminate y. Just eliminate one of the variables, and you'll be able to solve for the other variable. All right, so let x equal 7. We're not done, by the way. We have to solve for y. Let x equal 7 for, I say equation 1. It's a little easier. So 7 minus 2y equals 13. So negative 2y equals 6. Y is equal to negative 3. So therefore, the solution to the system is 7, negative 3. All right. So that was pretty friendly, because that system was designed for us to solve by elimination, because the coefficients, the magnitudes of the coefficients were the same, 2 and 2. Yes, one of them is minus 2, other one's positive 2, but the size of the coefficients were the same. Okay, let's see. Let's take a look at a system that is not as friendly. So an extension of the elimination method is to multiply one or two of the equations in a system by some number such that adding or subtracting will eliminate a variable. So let's see what we're trying to say here. So look at our first equation. X minus y equals 5. 3x plus 2y equals 15. So those are the two equations that make up this system. So when I look at the system, I can't add or subtract to eliminate x or y, right? Because the coefficients of x don't have the same magnitude, and the coefficients of y don't have the same magnitude. So what I'm going to do here is I'm going to eliminate, let's eliminate y, okay? Can you eliminate x? Absolutely. But I'm going to eliminate y. So if you want to eliminate y, what you want to do is multiply the first equation. You want to change this 1 to a 2. You want to change the 1 to a 2. So I need to multiply the first equation by 2, because 1 times 2 will be 2. So if you multiply the first equation by 2, the coefficients of the y terms will be opposites, right? Negative 2y and plus 2y. Then, if they're opposites, we're going to add the equations and then solve for x, because y is eliminated. Okay, so I'm going to take equation 1 and multiply by 2. So multiply the left side by 2 and the right side by 2. Please don't forget to multiply the right side by 2. That's the most very common mistake. Students are really good at multiplying the left side, but they always forget the right side. But remember, whatever you do left side, you have to do to the right side as well. So 2x minus 2y is equal to 10. I'm going to call this equation number 3. So what I'm going to do is I'm going to take equation 2, and just like I said before, I'm going to add it to equation 3, because I'm going to eliminate y if I do it correctly. So equation 2 is 3x plus 2y equals 15. And equation 3 is 2x minus 2y equals 10. I'm going to add those two equations. So this is going to be 5x, and I'm going to get 25. Oh yeah, 5x equals 25. This is beautiful. This is something I really want to see, because when I see that, I can solve for half the solution to the linear system. I can solve for x. X is equal to 5. And if I can solve for x, I'm very close to solving for the whole solution. I can find y. So let x equal 5 for equation 1, let's say. So 5 minus y equals 5. Y is 0 then. So the solution to the system, you can write it as 5, 0. And in this case, they want us to check. So we do a left side, right side table. 5 minus 0, 5. Beautiful. Left side goes right side. Let's check the second equation. Left side, right side table. So 3x plus 2y equals 15. So 3 times 5 plus 2 times 0, 15. Beautiful. Left side goes right side. So you see 5, 0 is a solution to both the equations that make up the system. Then that must mean 5, 0 is a solution to the system itself. Okay, so we're just gonna practice. We're gonna just make up 2 more questions here. I made up 2 questions, and I just want you to practice solving by elimination. I'm seeing this, and you know what? I'm just gonna change this equation, because for both the examples we did on the piece of paper, we added the 2 equations, but I want to subtract. So you know what? I'm gonna change this real quick. This is negative. This is plus. This will be negative 25. Okay. Okay, so I'm going to call this equation 1. I'm going to call this equation 2. I'm going to, because the coefficients are both, for the y term are both 3. They're both 3, so I'm going to subtract equation 1 from equation 2 to eliminate y, right? Because 3y minus 3y would be 0. And you'll see why I wanted to do that. So negative 5x plus 3y equals negative 25. 10x plus 3y equals 5. So I would argue students are really good at adding the 2 equations, but they make some common mistakes when they subtract the 2 equations from one another. Okay, so what you have to realize is negative 5x minus 10x. Okay, and be careful. If this was negative, it'd be subtracting by negative, which means adding. So in this case, I don't have negative 10x, so it just be negative 5 minus 10, so negative 15x. Now I put a bracket here because I don't want you to be confused. This means I'm subtracting one equation from another equation. I really don't want you to be confused with this being associated with the coefficient of the x term. That's why I put a little bracket here that distinguish whether, like, the difference between subtracting the equation and versus the coefficient being negative. Anyways, negative 25 minus 5. So this is a very common mistake. People usually put in, or a lot of students put negative 20, but it's not. It's negative 30. So just be careful when you're subtracting the 2 equations. So this will be divide both sides by negative 15. X equals 2. Let x equal 2 for, let's say, equation 2. So 10 times 2 plus 3y equals 5. So this is 20, negative 15. Alright, so the solution is 2, negative 5. Oh, there we go. Okay. Let's try to solve another system by elimination. So in the handout, we said that sometimes you have to multiply the equations by some value. You might have to multiply one of them or both of them. So right now, I can't eliminate x or y because the coefficients are different magnitudes. So this is magnitude of 3, magnitude of 5, magnitude of 4, magnitude of 3. So yeah, I can't add or subtract. But what I can do is I can, multiply. Okay, first we have to have a target, sorry. We have a target. Do we want to eliminate x or do we want to eliminate y? If you want to eliminate x, you want to find the least common multiple between 3 and 5. Okay, or you can think of lowest common denominator. So 3 and 5, the least common multiple is 15. And between 4 and 3, the least common multiple is 12. So you can take the first equation and multiply by 5, and the second equation multiply by 3 to eliminate x. So that's what I'm going to do, because I want to practice subtracting equations with you as opposed to adding. So I'm going to take equation 1 and multiply it by 5, because I really want that 15x. Oops, I'm going to show you all the steps here. So 5 times all of the left side, and 5 times all of the right side. So this could be 15x minus 20y equals 25. I'll call that equation 3. Okay, and we'll take equation 2 and we'll multiply it by 3. So all of the left side, all of the right side. Okay. And once you get comfortable, you don't have to show all the steps. You could just write the equation and equation 3 and equation 4. All right. So now we are ready to eliminate x, because I have 15x and 15x. So I'm going to take 3 minus 4. Equation 3 minus equation 4. Beautiful. I wanted to show you. Okay, so x. Okay, so negative 20 minus 9, negative 29y. Now here, be careful. 25 minus negative 33. So that's 25 plus 33. So that's going to be 58. Divide both sides by negative 29. Hey, negative 2. Beautiful. So, let y equal negative 2 for, let's see what equation. So many options here. Let's say equation 1. I think that's the easiest here. 3x minus 4 times negative 2 equals 5. If you do the math, this is 8 here. And then that'll be negative 3, so negative 1. Negative 1, negative 2. That is the solution to the system. You know what? There's actually, it depends on your comfort level with fractions. You never have to multiply the two equations. Okay, you can actually always get away with just multiplying one equation. But like I said, it depends on your comfort level with fractions. So I'll show you a shortcut if you want. So I'll do the same system. So 3x minus 4y equals 5. 5x plus 3y equals negative 11. So this is a bonus here. So same problem. Equation 1, equation 2. So what you can do is, you know what? Just be creative. What can you do? You can take equation 1 and multiply it by, you can multiply it by 5/3 if you want to eliminate x. 5/3, right? 3 times 5/3 is 5. Or you can multiply it by 3/4, because 3/4 times 4 is 3. So I'll show you. 5/3. 3x minus 4y equals 5/3 times 5. So this will be 5x. That's what you want. That's the whole point of multiplying by 5/3. This will be negative 20 over 3y, 25 over 3. I assure you, okay, well, let's call this equation 3. I assure you, if you take equation 3 and subtract it by equation 2, you will be able to solve for y and see that y is negative 2. Okay? Now, I personally, I have no problems doing this method. I feel it's a little faster because I just take the first equation and multiply it by some value. I don't have to touch the second equation, and I'm very comfortable with the fractions. But that's me. So if you're uncomfortable with fractions, just ignore this, okay? But all I want to say is you can always get away with multiplying just one equation. You just have to pick that value. It may not be a whole number. It might be a fraction. Okay, and if you multiply by a fraction, you're probably going to generate some fractional coefficients or fractional constants. Okay, so that's like a special way of approaching this. I'll leave you with this because I already showed you the solution to the system. I guarantee you the solution to the system is still -1, -2, but I want you to explore that idea. Okay, I already started you off with this. So just take equation 3 and subtract it by equation 2, and you'll still be able to solve for y because you'll eliminate x, and y is -2. Okay, so this is the last technique of solving a linear system that we're going to cover. So we're done graphing, we're done substitution, and we're done elimination.